Chemistry 9.5, we're still here, same day as 9.3 to 4. It's too cold for school, but it's not too cold to keep churning out videos. So 9.5 is where we are. So hopefully you found that very cleverly concealed 5 words that there's a thing called combination reactions. Next readings, they'll get into what these mean. We have on my board no combination reactions. As you read through the chapter, combination reactions will be one where you have a couple things going in and only one thing come out. So, sort of an obvious name for that. Decomposition reactions is in this list. We do have a decomposition reaction. Can you see? Yes. Can you spot which one do you think is the decomposition?
Is it the one with the acid?
No, decomposition is going to go, we have one thing in and a couple things come out. So that tip, you see it? One product, more than one reactant. Or excuse me, one reactant, more than one product.
Then 9.2a.
9.2a. So we have one on the left, more than one on the right. That's a decomposition reaction. Those usually require heat. You'll read about that in coming days. There's a thing called a single replacement. This one is a single replacement. Iron was a solo artist. Hydrogen was in with another thing. And they basically switched roles, where iron was alone, now iron's with chlorine. Before, hydrogen was with chlorine. Hydrogen is now the solo artist. It's kind of like at a dance, somebody cutting in to dance with somebody else. Chlorine was all alone and said, hey, hydrogen, I'd like to cut in. And chlorine said, boy, Fe, that iron is attractive, I'll dance with him. So we got Fe cut in. That's a single replacement reaction. Double replacement is there's two that like pull a switch. So, do I see a double replacement? I don't really see a great one of those. Save that for another day. Neutralization is like a special kind of double replacement. Some of these are neutralization reactions, but we'll save that for another day. But that's our list of 5. Combination, decomposition, single replacement, double replacement, neutralization. Might as well preview the next quiz while I'm just sort of on that subject. So next thing you're going to read is going to be 9.6. 9.6 is going to have name the 5 simple types of reactions and explain the one you read about in 9.6. So when you read about one of these in 9.6, you're going to do this same list of 5, but for the one you read about, you're going to explain what it meant. There's also 3 fill-in points from 9.6. They're going to be pretty obvious. They're definitely boldly highlighted and put off in the side margin. There's 3 fill-ins. So 4 new points, 1 to 5 gains a 6 point, and then these 3 fill-ins. Then we're going to trim some of the questions, and I'll let you know how that goes as we grade this. So today, number 6, it's an interaction among chemicals that brings about change. That's gone. The 4 events is gas produced, heat produced or absorbed, color change, appearance of an insoluble substance. That's gone. Chemical equation is a shorthand method of expressing chemical reactions with symbols and formulas. That's gone. 2 rules are gone. You have to know how the substances react and what new substances are formed, and the equation has to be balanced. 14, complete or molecular, pick one. That's gone. Mass not being created or destroyed is gone. Lavoisier, gone. And then here's what we keep. We keep the stuff name and describe down to the bottom. So reactants are the substances that interact with each other. They're on the left. Products are the substances formed. Those are on the right. The catalyst speeds up a reaction, increases the rate of the reaction, however you want to say that. but it's recovered unchanged at the end. So that's two half-point theories. Increases the rate of the reaction or speeds it up, recovered unchanged at the end. The two symbols stay. That's the arrow to separate reactants from products. The plus is the staying. That's separating reactants from other reactants, products from other products. G for gas, L for liquid, S for solid, AQ for aqueous solution. The arrow, the triangle is the heat is needed. The symbol above the arrow is that you need a catalyst. And then we have the same 6 guidelines from yesterday, which are write correct formulas for reactants and products. Pick an element you want to balance. Balance the polyatomic ions. Balance the H's and O's, kind of like at the same time as step 4. Make sure the coefficients are the simplest whole number ratio. So simplest is the idea, again, that we might have to divide if we didn't balance it the best way. Whole number meaning we can't have fractions. So we need simplest, we need whole number ratio, we need that all day. And then the last guideline there is just a jump. There is not homework off of this, but there will be homework off of 9.6. We'll start to balance again. 9.5 is just setting us up for each day as you read through 9.6, 9.7, 9.8, 9.9, 9.10. There's 5 more sections. Each section is going to specialize in one of these reactions. So 9.6 tomorrow, but the next 5 readings are going to be very similar, where they explain what the reaction means, and they're going to give you some stuff to balance. Just doing this more and more and more, but there's a 1-day gap of homework. 9.6 you'll be balancing, but everything you're balancing in 9.6 is like the reaction you'll read about there. That's it.